Alright, here's the problem. We got our giant capacitor bank full of a massive amount of stored energy that can explode at any second. But we don't want it all to explode in 1 second in a huge discharge. We want to slowly control it. 24 400 volt 10,000 microfarad capacitors all connected in parallel. And you have your DC out. In another video you can see how I wired this thing. Yeah, it is pretty large. Now what I want to do is take that immense unusable amount of power and turn it into a small amount of usable power. So here is my solution, which is kind of incomplete right now. This circuit is what I call the Ropar stack. It's a bunch of transistors and resistors that get hooked to the capacitor bank. You have different value resistors connected to the bases and collectors of these transistors, because at first you have quite a bit of voltage and you want it to drop over a certain amount of time. So as the voltage drops, you want less and less resistance. On the resistors on the collectors, you want the first one you have to have high resistance, and you want the last transistor you have to have less resistance on its base. But then there was this debate. The resistance values on the bases of the transistors, because the first transistor needs a lot of resistance on its base, so the base only sees 5 volts. And then when the next transistor fires, the voltage is slightly less, so it needs less resistance to fire its base. Now here's where the problem is, and where the circuit is incomplete. In this sketch, each base and collector is connected to the positive output of the capacitor bank. And since electricity takes the path of least resistance, it's just going to go to the gate with the least resistance, base there, and blow out that transistor. So it looks like I need to connect timers to each of the resistors on the bases. So when the voltage hits a certain point, the timer throws a switch that simultaneously switches from one base to the next. The transistors do have a tolerance percentage on the base. You would just have to keep it within the tolerance. And as soon as the voltage gets too low, it quits firing. And you would just have to switch to the next transistor that has less resistance on its base. And it would just basically pick up at the maximum amount of the tolerance. So let's take a closer look at the circuit. You have the capacitor bank up here. You have the resistors on the bases and the collectors of all the transistors. You have all the emitters coming down here and connecting to the load. You have all the resistors on the collectors connected together. And right here I have the switch that turns the whole thing on. You always want to break away from the power source, and I'm breaking away from the positive terminal on the capacitor bank. And it comes on here and it connects to all the resistors on the bases of each of the transistors. And like I said a minute ago, this circuit is incomplete. Or should I say, needs changed around. Well, thanks for watching. Please subscribe. And there's today's idea. I tell you, when you have good ideas like this jumping out at you, it's a real pain in the butt. This stuff just keeps you awake all night long.